Hello, this is Professor R.M. Mahendrakar. Today we'll be studying about the climatic factor, that is water. Now here we'll be putting more stress on water cycle. Water is one of the most important climatic factor. It affects the vital processes of all living organisms. It is the plenary agent that sets in motion the nutrients of the soil and makes them available to the plants. It affects the morphology and physiology of the plants. It, in combination with other factors, regulate the structure and distribution of plant communities in the biosphere. In nature, water is found both in liquid form and in frozen form. Now let us see the sources of water in liquid form. In liquid form, water exists in form of fog, mist, then in the clouds, in oceans, in seas, in rivers, wells, aquifers, then underground water, and the frozen water is present in the form of snow, frozen rivers and lakes, glaciers, icebergs, and the polar caps. The water vapor present in unit volume of air is called absolute humidity. The amount of water vapor required to saturate the same unit volume of air under constant physical condition is called relative humidity. Now we shall see about the hydrologic cycle or water cycle. Water moves through the hydrosphere in a cycle. Water collects in clouds, then falls to the earth in the form of rain or snow. This water gets collected in rivers, lakes, and oceans. Then it evaporates into atmosphere to start the cycle all over again. Thus, a continuous circulation of water from earth to atmosphere and vice versa in nature is maintained, and this is called water cycle or hydrologic cycle. The global water cycle can be described with 9 major physical processes which form a continuum of water movement. These are evaporation, condensation, precipitation, interception, infiltration, percolation, transpiration, runoff, and storage. Now this is an image showing you the diagrammatic view of water cycle. Now the water from the oceans is evaporated, it gets condensed into the clouds, then these clouds, then they fall down as rain, which we call it as precipitation. Then this water that falls on the land, depending upon the topographic condition, it may run off and join the oceans again, or it may get stored in river bodies, in other water bodies, and then some of it may get infiltrated into the soil, and some gets percolated deep into the earth crust through gravity. Then whatever the water that is present in the root zone area of the plants, it is again lost back to the atmosphere in form of water vapor to a process called as transpiration. Thus, the water in nature is a cycle. So this is a diagrammatic view of the water cycle. Detail. Evaporation. Evaporation occurs when the physical state of water is changed from liquid state to gaseous state. A considerable amount of heat, about 600 calories of energy for each gram of water, is exchanged during the change of state. Typically, solar radiation and other factors such as air, temperature, vapor pressure, wind, and atmospheric pressure affect the amount of natural evaporation that takes place in any geographic area. Now, the evaporation may be through the water droplets that are collected on the leaves. Evaporation through open sources of water, that is a lake. Evaporation, here it is an image showing you the water getting evaporated through these oceans. Then even during rainy season, you might have seen that water poodle gets collected in front of a house, and then when there is a bright sunlight, you'll see that the water is drying up. This is by two processes. One is infiltration into the soil, and the second is evaporation of the water by the radiant solar energy. The second physical process that operates in water cycle is condensation. Condensation is a process by which water vapor changes its physical state from vapor, most commonly to a liquid. Water vapor condenses on small airborne particles to form dew, fog, or clouds. The most active particle that forms clouds are sea salts, atmospheric ions caused by lightning, and combustion products containing sulfurous and nitrous acids. Condensation is brought by cooling of the air or by increasing the amount of vapor in the air to its saturation point. That is why most of the condensation occurs in the upper layer of the troposphere that we have seen already in the class of atmosphere as a climatic factor. When water vapor condenses back into liquid state, the large amount of heat, that is 600 calories of energy per gram that was needed to make it to vapor, is released into the environment. Now here, these are some of the images where you can see what you mean by condensation. Now this is a common phenomenon you see in your bathroom. That is, in the cold weather, when you take a hot water bath, you can see that the water vapors are condensing on your mirror. Then in the upper layer of the troposphere and in the tropopause layer, you can see the condensation of water vapor in form of clouds occurring here. The third process is the precipitation. At certain temperature and pressure, the maximum water-laden air is called saturated atmosphere. At saturation point, if the temperature is lowered, the water holding capacity of the atmosphere is reduced, which causes the condensation of water vapor in form of raindrops, dew, frost, sleet, snow, etc. This process is called precipitation. The coalescence process, as a water drop reaches a critical size, the drop is exposed to gravity and frictional drag. Falling drop leaves a turbulent wave behind which allows smaller drops to fall faster and to be overtaken to join and combine with the lead drops. That is how we can see in this image. Whatever the rain that is occurring here, it is due to the coalescence process. Now, ice crystal process. It occurs when ice develops in clouds or in cloud formation high in the atmosphere where freezing temperature occurs. When nearby water droplet approaches the crystal, some droplets evaporates and condenses on the crystal. The crystal grows to a critical size and drop as snow or ice pellet. Sometimes, as the pellet falls through the lower elevation air, they melt. The hail, a special type of precipitation during the summer season in the form of small ice pieces, may cause serious injury, especially to the young crops. Precipitation in the form of dew and sleet make a very vital contribution in the region of low rainfall. Dew and ground fog may be important to plants not only in coastal forest but also in desert near the sea coast where they provide much of surface water on which the ephemeral plants depend. The next process is interception. Interception is a process of interrupting the movement of water in the chain of transportation event leading to streams. The interception can take place by vegetal cover or depression storage in puddles and in land formations such as rills and furrows. Interception of water on the ground surface during freezing and sub-freezing condition can be substantial. The interception of falling snow and ice on vegetation also occurs. The highest level of interception occurs when it snows on conifer forest and hardwood forest that have not yet lost their leaves. Now, this is an interception caused in the low-lying areas where there are small depressions. Now, this is another interception caused by these natural craters and the natural dams. Walter Penck, a geologist, classified climate into three types based upon the precipitation and evaporation ratio. These are arid climate. In arid climate, the rate of evaporation is more than that of precipitation. Hence, the climate is always dry here. The second is arid humid. In these conditions, the amount of precipitation and evaporation are almost equal. Hence, we have an intermediate type of climate where it is both humid and arid. Then the third climate is a humid climate. In humid climatic condition, the rate of precipitation is more than that of evaporation. Hence, the atmosphere is almost saturated with water droplets. Hence, we'll have a humid type of climate. The fifth process that operates in water cycle is infiltration. Infiltration is a physical process involving movement of water through the boundary areas where the atmosphere interferes with the soil. The surface phenomenon is governed by soil surface conditions. Water transfer is related to the porosity of the soil and the permeability of the soil profile. Typically, the infiltration rate depends on the puddling of water at the soil surface by the impact of by the impact of raindrops, the texture and structure of the soil, the initial soil moisture content, the decreasing water concentration as the water moves deeper into the soil, filling of the pores in the soil matrices, changing in the soil composition, and to the swelling of wetted soil that in turn close cracks in the soil. Now, in this type of soil where it is very sandy, the infiltration is very fast because here the water goes on going deeper due to the gravity. Now, in this loamy soil, the infiltration rate is slightly slower because here the water molecules are held by the soil particles, and then the soil starts getting closing down and the cracks are also filled, so the rate of infiltration will be very less in this loamy soil compared to the sandy soil. And in stony conditions where the upper crust of the earth is covered with stones, now here the infiltration is very less and the percentage of runoff water will be more in such conditions. Now the next phenomenon is this percolation. Percolation is the movement of water through the soil and its layer by gravity and capillary forces. The prime moving force of groundwater is gravity. Water that is in the zone of aeration where air exists is called vadose water. Water that is in the zone of saturation is called groundwater. For all practical purposes, all groundwater originate as surface water. Once underground, the water is moved by gravity. The boundary that separates the vadose water and the saturation zone is called water table. Usually, the direction of water movement is changed from downward and a horizontal component to the movement is added that is based on the geologic boundary conditions. Now here you see how the water is moving or percolating deep into the earth crust by the force of gravity. Now soon after the rains, when you just cut a garden soil, you can see how the water is percolating deep into the earth crust due to gravity. The seventh physical process that operates in water cycle is transpiration. Transpiration is a biological process that occurs mostly in the day. Water inside of plant is transferred from the plant to the atmosphere as vapors through numerous individual leaves openings called stomatas. Plants transpire to move nutrients to the upper portion of the plant and to cool the leaves exposed to the sun. Leaves undergoing rapid transpiration can be significantly cooler than the surrounding air. Transpiration is greatly affected by species of plants that are in the soil, and it is strongly affected by the amount of light to which the plants are exposed. The eighth process is runoff. Runoff is flow of water after precipitation. It generally consists of flow that is unaffected by artificial diversion, storage, or other works that society might have on or in a stream channel. When each of the component flows enters the stream, they form the total runoff. This runoff water is actually not available to the plants. It goes and joins back to the oceans. When each of the component flow enters the stream, they form the total runoff. The total runoff in the stream channel is called stream flow and is generally regarded as direct runoff or base flow. Now here you can see the after precipitation, some amount of water has been infiltrated, some amount has been percolated, and the excess amount of water is just overflowing and joining the drains. Now here, depending upon the topographic condition of the soil, you can see it is a slopy soil, and after precipitation, the water is just running off from the surface and joining the streams. So all these are the examples of the runoff water. Now I shall say about storage. There are three basic locations of water storage that occur in the planetary water cycle. Water is stored in the atmosphere, water is stored on the surface of the earth, and water is stored underground. Now here you can see this is a picture showing you the storage of water in the atmosphere in form of clouds. The water stored in the atmosphere can be moved relatively quickly from one part of the planet to the other part of the planet. The type of water storage that occurs on the land and under the ground largely depends upon the geological features related to the type of the soil and the type of the rock present at the storage location. Storage occurs as surface storage in oceans, lakes, reservoirs, and glaciers. Underground storage occurs in the soil in form of aquifers and in the crevasses of rock formation. Now this is an example of the water storage on the surface. Now this is a depression caused by natural phenomenon where the storage of water has occurred. Even glacier also is an example for storage of water on water surfaces. And in the previous slide, we had seen that the aquifers also act as the storage of water, but this is an example for underground storage of water. Aquifer and the underground water table. All these are examples for underground water storage of water. So this is all about the water cycle. My dear students, now here we have seen what is the importance of water. We have seen in detail the different processes that occurs in water cycle. And also we have seen classification of plants based upon their water requirement. So thank you for your time given to me, and please take care of yourself and be safe. Thank you.